Welcome to our physics classroom. Good day, everyone. I hope you are all doing your learning activities in our subject and you are done with the lesson 5 that we tackled last time. For those who are incomplete, please make a completion for we will be ending this quarter. So I hope everybody is completed with the learning activities that I gave you last time. Today, we're going to tackle potential energy. So, what is the meaning of potential energy? An object can store energy as a result of its position. So, an object can store energy when it is on its position. Furthermore, potential energy can be defined as a stored energy of position possessed by an object. So when you see an object on a certain position, it means that object has its potential energy. Just like in this example, you see this boy, no? As it moves, it has kinetic energy. When stopped, it has potential energy. So because it is in a certain position. So this is an example of kinetic energy to potential energy. So it has a energy that is being stored due to its position. Another example, somewhat a higher altitude would have a greater potential energy. Potential energy can be transferred into kinetic energy. From this example, as you can see, kapag nandito yung child, no? As you can see, meron siyang potential energy. So, from potential energy converted to kinetic energy kapag nag-move. So, dito, mataas ang kanyang potential energy. Habang bumababa siya, bumababa yung potential energy, tumataas naman ang value ng kinetic energy. Okay. Okay, for example, the heavy ball of a demolition machine is storing energy when it is held at an elevated position. So, this is an example. No? So, we have this one, a heavy ball, and it is being held by the demolition machine. So, this ball stores an energy. No? Kapag ka siya ay nasa elevated position. So, from this position, it stores its energy. And that is as an example of potential energy. Similarly, in this example, a drone bow is able to store energy as a result of its position. So, ito, nakaganyan siya. Nakastop pa siya, hindi pa nire-release nung man. So, this also example of a potential energy. As we go on, you'd be able to understand it more. No? So, the massive ball of a demolition machine and the stretch bow, this one, possess store energy of a position, and that is an example of potential energy. This example that I've shown you, these two examples, also illustrate the two types of potential energy. No? The first one is considered as gravitational potential energy, and this second one is considered as elastic potential energy. So these two are the forms of potential energy. So let us define them one by one. For gravitational potential energy, it is the energy stored in an object as a result of its vertical position or height. So in this example, so I have here a box. No. As you can see, it is elevated with a height of 2 meters from the table, 2 meters from the table. So this object stores its energy for its vertical position, and the energy stored by this object is considered as the gravitational potential energy. And another definition for gravitational potential energy is that energy is stored as the result of gravitational attraction of the Earth for the object. So, kaya nga tinawag natin yung gravitational potential energy because this energy is due to the gravitational attraction by the Earth. As you can see in the example, this is the Earth's surface, no? It is being held by the gravitational pull of our Earth. Kaya nga kung walang gravity, syempre magpo-float tong mga object na to. But because of the gravity, so they are stays in put. So this one is a perfect example of a gravitational potential energy. Another one, gravitational potential energy in this example is it is a pendulum. So this is a moving pendulum. So we have here this picture, no? It is moving as the pendulum moves. It shows that when the gravitational potential energy increases, the kinetic energy decreases. Why? Because as you can see, when the pendulum reach its highest position, the potential energy is high. As it goes down, the potential energy decreasing and the kinetic energy increasing because the gravitational potential energy changes from uh, gravitational potential energy to kinetic energy when the objects move. No? So in this case, the pendulum has a gravitational potential energy higher on its highest position or top position. As it goes down, gravitational potential energy decreases and the kinetic energy increases. No? So as you can see in this one, there is a direct relationship between gravitational potential energy and the height. So meaning, as the object increases its height, the gravitational potential energy increases. So as the object decreases its height or mas bababa siya, no, the gravitational potential energy also decreases. So there is a direct relationship between the gravitational potential energy or GPE and the height. Now, let us consider the equation for gravitational potential energy. As you can see, we said a while ago that there is a direct relation between the gravitational potential energy and the height. So meaning, as the height increases or the object is in a higher position, the gravitational potential energy is high. So when it is in a lower position, the gravitational is much lower. So there is a direct relationship between GPE or gravitational potential energy and the height of the object. So from this concept, the equation for gravitational potential energy would be this one. So let us discuss this one. So it is equivalent to the m for the mass of the object, g is the acceleration due to gravity, and h for the height of the object. Mass is expressed in kg, and the gravity or g is expressed in the 9.8 meter per second squared. So that is the acceleration due to gravity. And of course, height is in meters since this is a length. Unit for potential energy. So let's flash the equation that we've already discussed. So that is PE is equal to m multiplied by g to h. So from this equation, the unit for gravitational potential energy would be kg meter per second squared m. So kg for mass and meter per second squared acceleration due to gravity and m. Furthermore, we can compress this unit into Newton meter. So we know that kg that ms squared is equivalent to Newton. So just write m. So this is also same. Furthermore, we can compress this one into single unit, and that is joule or J. So the unit for potential gravitational potential energy or potential energy rather, we can use joule since that is energy. We know that the unit for energy is in joule. So, pwede nyo gamitin kahit alin dyan sa tatlo na yan. So, it is better if you use this one if meron kayong gustong makancel. And kapag sa solving naman, meron Newton meter and may ika-cancel, ito yung gagamitin. And for the final answer, pwede nyo siyang express in this form. So, now we're done with the gravitational potential energy. Now, let's move to the second form of the potential energy, which is elastic potential energy. So, when we say elastic potential energy, it is the energy stored in an elastic material as a result of the stretching or compressing. So, kanina sa potential energy, it is stored due to the height or position of the object. In this type or forms of potential energy, this potential energy is stored in an elastic material. So later on, I'll give you example of elastic materials. So like this one, so we have spring, no? Kapag naka-hold siya in this, yan, mataas ang potential energy niya. Pero kapag ka naka-stop lang siya, tawag nito, naka-stretch or stretch na yung spring, mababa na yung potential energy niyan. So, kapag ka mas nakadiin siya or naka-compress, mas mataas ang potential energy niya. So, this one is an example of elastic potential energy. So, we know that this string is an elastic material. So, madali naman tandaan pag elastic potential energy. So, for elastic potential energy, no, it can be stored. So, ano ba yung mga elastic material, ma'am, na sinasabi mo? So, these are the rubber bands, no? Like this one. So, we have rubber band. So, it stores an elastic potential energy. And we have a bungee cords. So, this one. So, the bungee cords is an elastic material that stores an elastic potential energy. And a trampolines, no. So, trampolines, this one. This also stores an elastic potential energy kasi elastic tong mga material na to. Na? Spring, I already gave you a while ago. So that elastic potential energy, there is a special equation for spring that relates the amount of the elastic potential energy to the amount of stretch or compression and the spring constant. So dito, meron tayong tinatawag na spring constant. So I'll show you the equation for elastic potential energy para makapag-proceed na tayo sa solving. Okay, so this one is the formula to be used or equation to be used in solving the elastic potential energy. So that is P spring is equal to 0.5 or pwedeng 1/2 multiplied by the K. Ma'am, what is K? That is the spring constant. So ibibigay ko yan sa problem mamaya. So spring constant, no? Ito yung Newton per meter. So that is the force required to stretch elastic material, no? Multiplied by the x raised to 2 or x squared, and that is the amount of compression relative to the equilibrium position. So, x is yung length, no? Length of compression. No? That is expressed in meter. So, furthermore, you'd be able to understand about this equation more pag meron na tayong example. So, let us proceed in the calculation for you to be able to apply the equation that I've shown you a while ago. So, for this, make sure that you have your paper, your ball pen, your marker, and your calculator that you're going to use in solving problem. So, let us proceed. We know that we're going to solve problems, and I always want you to use this very helpful mnemonic. So that is GRESA. So GRESA again is a mnemonics that requires to find the given, required, equation, solution, and the answer. Okay, so here's the first problem. If you want to solve the first problem with yourself, knowing the equation, you may pause the video and then play it when you have your answers to check if you got the correct answer. For now, if you want to learn with me, so just follow. So let us solve this problem. Let us read first the problem. A cart is loaded with a brick and pulled at a constant speed along an inclined plane to the height of a seat top. If the mass of a loaded cart is 3.0 kg and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart at the height of the seat top? So again, for solving or in solving this problem rather, so we need to find the given, the required, the equation, the solution, and the answer. So from the problem, we see the given. So these are the unit with numbers. As you can see, we have 3.0 kilogram and 0.5 meters. So 3.0 kilogram, that is equivalent to the mass. and 0.45 meters. So that is maybe the equivalent to height. So as you can see in the example, the height of the seat top. So that is the height. So just write this given to the part. So M is equal to 3.0 kg and height is equal to 0.45 meters. And then G is equivalent to 9.8 meter per second squared. In this problem, it is not included the G, but obviously you know the value of the G, which is 9.8 meter per second squared. So just write this one for you to know what are the given in this problem. And we need this one as I shown you the equation a while ago. No, so we need the value of the G. So that is the acceleration due to gravity. Always remember this value. See, it is very helpful. From the problem, it is stated that we need to find the potential energy. So just write down the potential energy to the required part of your solving. And then the equation would be PE is equal to mgh. Now we have the given, we have the required, and we have the equation. We can now substitute this to the solution. So that is PE is equal to 3.0 kg multiplied by the acceleration due to gravity, which is 9.8 meter per second squared, and height, which is 0.5 meter. Doing the math, the answer would be 13.23 kg meter per second squared multiplied by meter. So as you can see, I write this equation. We will combine this equation kasi multiplication yan. No? Pwede pa nating i-compress yung unit niyan. So, this would become 3.23 kg meter per second squared is equivalent to Newton meter or Joule. So, kahit alin dyan yung sagot nyo. So, for final answer, pwede na natin gamitin yung in Joule since that is more compressed. No? Single unit. Okay, here's the second problem. An object held at a point above the ground has 2,352 joules of gravitational potential energy. The object mass is 20 kilogram. How far above the ground is the object? So for this problem number 2, you will be the one to solve this one. No? Just pause the video for about 5 minutes and then answer this problem. And after that, if you have your answer with you, just play the video and then let's check if your answer is correct. Okay, you may pause the video now. So let's say you have your answer with you. Let us check. No? So you played the video already. So in this problem, again, we will find the given, the required, the equation, the solution, and the answer. Okay. From the problem, it is clearly stated that the value of the gravitational potential energy of the object is given, and that is equivalent to 2,352 joules. And the object mass is 20 kilogram. Okay, so just write this given to this part. So, PE is equal to 2,352 joules and mass is equal to 20 kilogram. And we also have another given which is not stated in the problem, and that is the value of the G, which is equal to 9.8 meter per second squared. So it is not given in the problem, but it is necessary to write it here for you to include it on your solution. It's better to write it down na. Okay. From the problem, it asked or it required us to find or to know how far above the ground is the object. So that is equivalent to height. So height is the missing one. The equation would be P is equal to mgh. As you can see in the problem, this is the equation, but the required one is the height. So we need to derive the formula na kung saan the height value would be here. So let us derive the formula. So the formula would be H is equal to PE over mg. So I just divide both sides to the units with the height. So that is mg. So if you divide both sides with mg, so cancel mg here. So naiwan yung height. So height is equal to PE divided by the mass multiplied to the g. So we already have, or we derived the equation. We can now proceed to the solution. Okay. So solution would be like this. So we have 2,352 kg multiplied, or PE, that is kgm squared multiplied by m. So as you can see, sinulat ko lahat ng unit dito para makikita natin yung makakancel. Kasi yung joule, that is equivalent to kg meter per second squared multiplied by m. No? Instead of writing joule here, kapag sinulat ko kasi yung joule dito, hindi siya makakancel. So I use the expanded unit for you to know what are the given that, or what are the units that we're going to cancel. And then the value of our mass is 20 kilogram, and the value of our G is 9.8 meter per second squared. Meter per second squared. So the answer is 12 meter. So this is the next problem. Again, if you want to know the answer, just solve it by your own. So here's the problem. Let us read it first. A compressed spring has 20,000 joule of stored energy. If the spring constant is or the value of a K, so that is constant kasi, so binibigay na yan sa problem. Sa last ninyo, ibibigay ko na rin yung problem or yung value ng K. So that is constant. In this case, we need to find or to know how far the spring compress. No? So we're going to find the X, the value of the X. So let us solve this together. If you want to solve it by your own, just pause the video and then play it when you have your answer. Let's say you have your answer with you. Let us proceed with the solution. So let's find the given, the required, the equation, the solution, and the answer. For our given, in the problem, we have 20,000 joules. And so just write it down here, 20,000 joules. Okay. And another, we have 1,500 Newton meters. So that is the unit of the K. So in this problem, mga anak, hindi to potential energy. So as you can see, we have an elastic material, that is the spring. So we will use the equation for elastic potential energy to find the, or to solve this problem. So we have the value of our K, so that is K is equal to 1,500 Newton meter. So that is the unit of our K. So that is the force required per length. Okay. In the problem, stated that, again, I forgot, we need to write the value of the G because it is included in the equation. So for the problem, how far? So magdaderive tayo dito. So that is how far the spring compressed. Just write it down. And the equation, PE is equal to 1/2. So pinakita ko kanina, 0.5. Pwedeng 1/2 din. 1/2 multiplied by the value of the K multiplied by the how the compression. So tinutukoy ng X dito is the length ng compression ng spring. No? So that is the X squared. So, as you can see in the required, X ang hinahanap, not PE, or the elastic potential energy. So, we need to derive the formula. So, in deriving the formula, just multiply this one, no? Or, pwede i-cross multiply, and then pwede din tayong mag-cancel out. So, just like this one. So, I write here PE. So, ang kasama kasi nung X squared is the 1/2 NK. So, nilagay ko siya dito. So, it will be the equation. So, deriving the formula, ito, PE, 1/2, ito, tinanggal ko lang tong kasama niya, nilagay ko siya sa ilalim to cancel out. So, mawala na siya ng kasama, no? Yan. And then, as you can see, we have X squared. So, we need to square root this one, both sides. Ayan. So, this would be the final equation. X is equal to square root of PE over 1/2 K. So, nakaderive na tayo ng formula. Pero kapag ang hinahanap is elastic potential energy, you don't need to derive the formula. Just use this equation. But in this case, it is asking how far the spring compress. So we need to find the compression, the length of compression, no? So we need to derive the formula. So this is the formula if you want to find the value of the x. Okay, so let us solve since we have the equation and we have the given. So just substitute the given to the equation. Okay, so x is equal to square root of the 20,000 Newton meter. So I use Newton meter here because we have Newton meter in the K. And then I write down 1/5 or 1/2, sorry, multiplied by 1,500 Newton per meter. So this is the 1/2, this one, and the value of K. So I just substitute this given to this equation and it goes like this. So this is the value of the PE, this is the 1/2, and this is the value of the K. So from the problem, let us solve this one. And as you can see, we can cancel the value of Newton. That's why I put it here Newton meter. No? Kasi pag joule ang nilagay ni ma'am dyan, we cannot cancel the value of this one. If kg meter per second, that meter naman, hindi mahirapan din tayong mag-cancel out. So, it's up to you what unit you're going to use as long as you can cancel them in your problem solving. So, yung meter, hindi natin siya pwedeng i-cancel because it is in numerator and this one is in denominator. No? So, we need to multiply them. No? So, that is, the answer would be, doing the math, so the answer would be 26.6 meter square meter. So we need to square this one. So the answer is 5.16 m. Okay, so you can find the evaluation in the Google Classroom. No, nandun na, pinost na ni ma'am. So if you have question, just PM ma'am or just write a comment on our Google Classroom. Thank you, everyone. I hope you enjoy our discussion and you may now answer the learning activities I posted in the Google Classroom.